There's a massive rogue object wandering our cosmic neighborhood. Researchers have made another fascinating discovery within our cosmic neighborhood. Astronomers have found an eerily mysterious object flying around our cosmic neighborhood, and it has experts intrigued. The object has a mass 12.7 times greater than that of Jupiter, and a surprisingly powerful magnetic field. Even more interesting is that it's a rogue object not attached to any other object in its vicinity. All of this was found by experts using the Very Large Array Radio Telescope. The Very Large Array, VLA, is a collection of 27 radio antennas located at the NRAO site in Socorro, New Mexico. Each antenna in the array measures 25 meters, 82 feet, in diameter and weighs about 230 tons. Experts guess the object, dubbed SIMP J01365663 plus 09334773 in question, is at a boundary between a supermassive planet and a brown dwarf. This object is right at the boundary between a planet and a brown dwarf, or failed star, and is giving us some surprises that can potentially help us understand magnetic processes on both stars and planets, said Melody Kao, who led this study while a graduate student at Caltech, and is now a Hubble postdoctoral fellow at Arizona State University. And if we take a look at a working definition laid out by the AOR Working Group on Extrasolar Planets, a brown dwarf is an object that is too small to produce hydrogen fusion, the dominant process that generates energy in stars, but is still large enough for deuterium fusion, a lower temperature process vital to newly forming stars. Therefore, brown dwarfs are objects too large to be considered planets, but not big enough to withstand the nuclear fusion of hydrogen in their nuclei, the process that fuels stars. Initially, it was believed that they did not emit radio waves, but the discovery in 2001 by the VLA of a radio flash in one of these stars revealed strong magnetic activity. That's a bit strange. Why? Well, on Earth, auroras are generated by solar winds, which interact with the charged particles in our ionosphere. The charged particles travel along the lines of the planet's magnetic field toward the poles, where they manifest as lights in the sky and produce strong radio wave emissions. And that's where the mystery deepens. As far as we know, and yeah, we don't know everything, brown dwarfs aren't in the vicinity of any solar winds, making their auroras something of a puzzle. SIMP J01365663 plus 09334773 features a magnetic field so powerful, it is 200 times the strength of Jupiter's magnetic field. The group of researchers also believes that they may have intercepted radio emission coming from the object's auroras, which presents a challenge to how we understand the mechanisms for auroras in both brown dwarfs and exoplanets. This particular object is exciting because studying its magnetic dynamo mechanisms can give us new insights on how the same type of mechanisms can operate in extrasolar planets beyond our solar system, Kao said. We think these mechanisms can work not only in brown dwarfs but also in both gas giant and terrestrial planets. Detecting SIMP J01365663 plus 09334773 with the VLA through its auroral radio emission, said astronomer Greg Hallinan of Caltech, also means that we may have a new way of detecting exoplanets, including the elusive rogue ones not orbiting a parent star.